Okay everybody, this is my attempt to build a Chinese radio kit on video. I got this one from Banggood. This one, I actually got 3 radio kits from Banggood. This one hopefully will be the simplest. It's obviously a knockoff, Panasonic brand name. Looks similar enough. The directions aren't very useful. I don't read simplified Chinese. Well, not very well anyway. So let's give it a go. This kit doesn't look too bad. Looks like a fairly simple radio kit build. Nothing too strange. Now, since I'm colorblind, I'm going to use my component tester. Resistor color codes are absolutely no use for me. Okay. So, LED, plastic components here. So I'm going to sort out the components here. A couple bits of wire. In many ways, this is just an experiment. I'm trying to get the hang of proper lighting, camera, microphone, and editing techniques. So this is going to be completely off the cuff and unedited for now. Well, maybe slightly edited. Put a few little capacitors here. Fortunately, I have many of these parts that I was able to get as very cheap assortments. So I have extra capacitors, extra resistors, etc. Looks like this is the AM antenna, maybe. Bunch of 104s and a smaller one here. 202s. Little inductor. Looks like it's going to be a lot of inductors. Excuse me, a lot of capacitors. Not many inductors. Not many screws, although I see 3 different types so far. It's very interesting. Okay. 2 sets of self-tappers and 3 metal screws. It looks like 2 different types. Transistor, a switch, headphone jack, I think. This will warm up the soldering iron. I like to use 400 degrees Celsius. I don't know if that's high or low, but it seems to work for me. I don't really grok Celsius well as an American. 400 is just a number, really. I don't really correlate it to anything. It's like a setting of 8 out of 10 or something like that. It's just a number that seems to work. We really don't think in metric in the United States unless it comes to, a 2-liter bottle is a very commonly used measurement. And here and there we use the metric system. I know that in vehicles there are 16-inch wheels in Europe, and what we call SAE units still have a place in the rest of the world, but just as we're slowly adopting the metric system in the US, it'll happen eventually. Okay. Alright, so what I'm going to do here is I'm going to start with the resistors. I'm just going to go ahead and test them as I go. When I find a value, I'm going to put it in the in circuit. Alright, let's see if I can put it on camera here. This is a 9835 ohm resistor, so it's a 10 k ohm resistor. Okay, it looks like it goes right here. Spacing of the holes is kind of tight here. Not sure it's quite ideal. I like to get my resistors lined up as much as possible, but I do not align them by color because to me it makes absolutely no difference. It's green or brown represents the same thing to my eyes, or red really sometimes. They all sort of blend together, so to speak. So, and obviously polarity doesn't matter, but some kit builders like to align the colors in a certain way. That doesn't mean anything to me. It's a useless indication anyway. Okay, let's go. My soldering isn't perfect, but hopefully it's getting better with time. So what I do is I tack it down lightly with a small amount of solder, and then I realign it nicely. That looks good. And then I flow a bit more solder on. Well, I flow solder on the other side, and then that looks okay. And then this side needs a bit more. There we go. Okay, that's good. I'm going to use my cheap Chinese-made, unfortunately, Craftsman wire cutters for now. They're fine for these purposes. Okay, next resistor. Okay, this one is, let's see here, 2218 ohms, so that's telling me it's a 2.2 k ohm. Okay. 2K2 looks about right. 2K2 it is. Same procedure as before. Tack up one leg, get it lined up nicely, and then get the other leg, and then there we go. Note that I use lead-based solder. It's tin lead. It works a lot better than lead-free solder. The danger of leaded solder is way overblown. I don't even know if there is any, to be honest. No danger whatsoever to it. Let's see here. Yeah, that'll have to do. Let's throw a little bit more on there. And clean up this joint here. Definitely not perfect. Okay, next resistor. You can imagine how difficult it was for me to do my circuits courses when I was in college. Not being able to visually inspect any of the resistors. And there weren't $20 Chinese transistor testers you could buy back in those days. So this is telling me 98.63K, so that's 100K. Ohm resistor. I think 1K5 is the matching place that it goes in. 1 times 10 to the 5. Nowadays resistors are mainly surface mount, so everybody's colorblind, effectively. I mean, non-surface mount components are used, you know, in high power applications and things like that, but pretty much in normal electronics, it's all surface mount nowadays. So, the olden days, I guess, surface mount were labeled by number somehow, but the components are so small that, you know, it just can't even fit a number on there anymore. Okay. That's good to me. I may touch up my solder joints later on. Alright, next resistor. Yeah, the colors on these is not something that I can easily discriminate. So it's hopeless. Okay, next. This one looks like 22 ohms, almost on the dot. Okay. There it is right there. Yeah, sometimes I can distinguish colors. I can definitely distinguish colors by context, based upon where a color is. I can tell you what color it is. And that's just rote memorization. I learned how to do that when I was in kindergarten. So I will never tell you an illogical color for anything. If you hold up a picture with the sky that's purple, I'll tell you the sky is blue. Because by default, I will give you a logical answer. But I can be tripped up. It happens. Memorization is key. I became very good at it at a young age, so that helped me later in life. You have to memorize things that other people don't have to bother with. Memorizing attributes about things that people, you know, don't even bother to learn. Long lists of what colors things are supposed to be, for example. I'm thinking maybe my color vision has gotten better over the years, but I could be mistaken. It seems to have changed somewhat. So I think this is going to be video part 1, just a test. It's going to be strictly me putting on the resistors because this looks like it's going to be a very long video if I just record it in one go. So let's call this part 1. It'll just be the resistors, and you'll be able to see my struggle with color blindness, and then that'll be the end of it, because everything else is, clearly differentiated with a label, or it's just a different component type. Okay, next resistor is 672 ohm. So why do I, work on circuits even though I'm colorblind? Well, I mean, why not? I mean, why were electronics components designed to basically make it extremely difficult for 8% of the male population? Because in general, electronics is a male-dominated profession. I wish there were more women in the profession, in electronics, in engineering in general. So before I lose my train of thought on that subject, let's quickly put this component where it belongs. So pretty sure that was a 6, goes into 680 here. Yeah, when I took electrical engineering, it was a male-dominated field. There were very few women in any of my classes. It was rare to even have one. Hopefully things have changed. The computer science, computer engineering courses I took were not much better in terms of gender disparity. 1 to 2 women, maybe 3 per class. And that's sad. Hopefully that's gotten better in the last, 20 years. And when I visited MIT, they seem to have a lot more female students than the engineering department at my school, which is one thing I liked about MIT, but it's way out of my budget. I did get a mailing from MIT. I don't know if that was an acceptance or that was just a tease, but I don't know if they were trying to invite me to MIT or not, but it would have been cool to go there, that's for sure, if I had the money. Would have been a different experience. Might have been quite similar, though. You never know. I went to a state school. You can find out if you do a little research. Alright, next resistor we have at 4.82 ohms. So I'm guessing that's supposed to be 5 ohm, maybe? Or something? Let's see. 4.7 ohm, that's right. Yeah, resistors have this odd scheme for their values. I'm sure there's a reason for it. It didn't always used to be like that. In very old equipment, you see things like 10 ohm resistors and stuff like that. Not 9 point something or other. Oh, that's just the way it is. I'm sure there are great reasons for 4.7 being the standard value and not 5.0. Again, not the best soldering job, but I think it'll work. My dwell time isn't so great, but luckily components nowadays are pretty immune to overheating. Haven't burned a component yet, except, well, I've burned items on Nintendo motherboards that were made out of plastic that basically one-use components that I was scrounging, and I've actually been able to surface mount solder some things that were not meant to be reused, and I've had a lot of success, but occasionally I do melt things. Never melted a resistor or a transistor or capacitor for that matter, or even an LED. I'm lucky with the standard things that you see here. Next one is 1489 ohms, so 1.5 k ohm. Let's see where that might go. Well, let's see where that one goes. I see. Boy, that's really hard to read. Alright, I'll set this aside. Next. Oh. No, unknown, or damaged. Kind of humorous translations. There are some reasons for mistranslations. For example, Chinese doesn't really have a equivalent to ending a word in S or ES as we do in English and many other European languages. It's inferred by context. That's why when you see a translation from Chinese, you'll see the number being wrong, either singular where it should be plural or vice versa. So here we go, we have a 33, oh, I better test it again. I'm getting a little bit distracted here. So we have a 33k ohm. Let's see if I can find that. Alright, 33k. It's right there. Okay, so in this case we have to do a little trick of going like this. I don't know what else to call this. Making the resistor stand fully erect here. Okay. So I'll try to make that look better without burning my finger. Still burned it a little bit. Some of these cheap Chinese kits are a little bit haphazard in the layout, but that's okay. They really are great at keeping the price down. It's amazing how they're able to economize. It's funny, the Chinese government's actually trying to increase the value of the currency, but it's something that American government officials have been asking for a long time, but economic factors are preventing them from doing that. So they're not artificially lowering or deflating the currency anymore, or at least it doesn't work for them anymore. It's causing undesirable problems. But I feel like China will eventually become like Japan in terms of manufacturer of high-end goods and Western quality goods. They already have a lot of high-end goods you can buy in China that are quite nice, and they make things that you just don't see in the West, especially niche electronics devices. So my only problem with China, of course, is the same problem everybody has. They really need to work on their human rights record. And we have a huge prison population in the United States, but in China you can be in prison just for pissing off the wrong government official. I don't think there's anything you can say in the United States that makes you go to prison, but you can say the wrong thing in China and wind up there. That's my biggest problem with China. Alright, so 324 ohm. So it looks like it goes in this one. Now this one doesn't have to stand erect. I don't think it'll fit in the little... Everything's a bit tight, but if I manage to mess up any of these leads, I have a huge bag of 1,000 resistors of, probably all of these values. So I'm not too worried about, breaking any of these components. Certain other components I am worried about, but not the resistors. Alright. I have hope for China. Democracy will come. I feel like it will. The Chinese society is a very technocratic society. In other words, the best ideas win. But it just hasn't been true of the government. Then again, who really runs the government? Quite honestly, bureaucrats run the government. The Chinese Communist Party. Do they really run the government, or do they just sort of the figureheads at the top, and the million plus, maybe 10 million government workers in the bureaus, just like we have in the United States in the State Department and things. There are just thousands and thousands of people who do the job regardless of who is leader, and they would do it the same way. They have to follow the same laws. Of course, the laws that you have does change depending upon party in power, but laws are very slow to change. So, but I do have hope. I feel like China becomes a leading democracy, having them as a totalitarian state. It just can't be very good for the future of this world. I'd like to see some changes. Hopefully people will demand it. Okay, we have a small number of resistors remaining here. Let's see if I can wrap it up here. Now this looks like it says 100K, so I'll keep testing. Alright. Pretty interesting logo. It looks like a transformer. This one is 21.72K, so 22K. Let's see if I can find a 22K on this board. Yep. I've made this point on some of my videos, is that the cheap Chinese electronics that we're able to get has really made our lives a lot easier. We've lost manufacturing, that is true, but we're able to do services that we could never do in the past. For example, I'm using these cheap Chinese tools, soldering iron, etc., solder wick, solder flux, to fix Nintendo consoles, and that's a service that I wouldn't have been able to afford to provide. But obviously it's not my main job. I'm a computer programmer. That's my specialty. And that's what I've been doing since I was 11 or 12. And that wasn't a very good job anyway, was it? So the idea is with the tack is just to tack it in place, and I wasn't paying attention, so I didn't even tack it in place. Alright, there we go. So once you tack it in place, you can align it nicely. Again, my soldering technique isn't the greatest, and I'll probably want to touching up some joints later on. It can be very relaxing to do soldering. What's relaxing about it is if you make a mistake, you know, it's not the end of the world. This kit was, you know, $10. When you get these kits from China, though, they do take a long time to get here. Where I live in the United States, packages tend to get stuck in customs in Chicago for I don't know how long. You don't really know how long they're in customs for, to be honest. Because it doesn't show up on the USPS site until after it clears customs. So generally, packages can take anywhere up to 8 weeks, but in the best case scenario, they take 3 weeks. But in any case, it's not like getting things from Amazon in 2 days. So, you know, getting this kit probably took about 3 weeks. I got this one from Banggood. That's one of those Chinese sites. It's a very nice site. I like it. Happy. Everything I've ordered, I've received. Alright, so this is a 4.7 ohm resistor. Let's see if I can find it. There it is. So, why did I get into programming when I was, 11 or 12, you might ask? Well, I was very lucky. One Christmas, when I was in 5th grade, I received a Commodore 64 from my parents, and I'm pretty sure my grandfather paid for it. And I also received a disk drive. And, you know, in a lot of countries in Europe, I guess, Commodore 64s were not really used with disk drives, but I don't think tape drives were that popular in the United States, so you really had to have a disk drive. And when I say disk drive, I mean low density 5 1/4. And back in those days, you know, if you owned a computer, you programmed it. I mean, you could just play games on it, but it was just so much more fun to be able to type in, you know, basic programs from those magazines, and I even typed in long hex listings. Very tedious, not relaxing at all. But you know, pay $3 for a computer magazine, you get all these games for free, but you got to type them in. So I became a very good typist. I actually took a typing course when I was in high school. It was all women except me, maybe one other man in there. Obviously, you know, secretaries or something like that, administrative assistant, and but yeah, that was one of the smartest courses I've ever taken in high school, was typing. You know, I was obviously an honor student, but I really liked people in my typing class. They were really cool people, and it was extremely useful. I think all programmers should learn to be touch typists. It just helps quite a bit. Alright, we're at about 40 minutes. Hopefully I'll be able to wrap it up here soon. and this will be part one, just getting the resistors sorted and talking about my life. Hopefully you'll find it interesting. Alright, this one tests out at 1000 ohms, so 1K. Alright, there it is. A lot of these kits are clones or copies of kits made by, in some cases, European manufacturers. But I know that we'll start to see, and you know, kits from the 60s even. The Chinese factories have basically brought a lot of things back to life, and that's nice. Just in searching for something to do, I mean, there's so much capacity. But I think what we'll start to see, if we're not already seeing it, are some original kits. And I'm seeing some ham radios and things from the Chinese that are just... So anyway, as I was saying before, my camera phone overheated and cut the video. Seen some innovative stuff out of China, for example, in ham radios. I was in the hobby active when I was a teenager, and now I'm seeing some very, very inexpensive ham radios coming out from China that are using some lithium-ion batteries and some programmability. And again, I haven't really been active in the hobby, so the Japanese vendors might have actually been doing that for a while. But the Chinese radios are so inexpensive, it's pretty amazing. So it looks like I have a spot for a 100K resistor here, and I don't see a 100K resistor here anywhere. I do have extra resistors, but I actually have a resistor that I have not yet mounted. So a little bit of a mystery here. So I'm going to do some troubleshooting here with my meter. See if I put the resistor in the wrong spot, maybe. See if I have 100K somewhere else. Measuring resistance. See if this shows up. Yeah, it's a little bit at an angle, but not horrible, I guess. Alright. This one is a 10K. This one looks like a 2K. That one's out of range. $670. I won't measure the ones that are standing up just yet. $330. That one's 100K. Is it supposed to be? Nope. That's supposed to be a 1K5. Maybe 1K5. I misread that. I think I did. So, yep, sure did. To all you clever people out there, it should be obvious what I did. But I read 1K5 as 1 with 5 zeros, but that's not correct. That's just indicating 1.5 kilo ohms, or kilo ohms. So I'm going to unsolder that. It'd be nice if I could read Chinese. I am working on it. Let's see here. Is it the right one? Nope. Slowly but surely, as I drop the resistor on the floor. I feel like Chinese is very poetic. For example, numbers are inferred by context. That in itself is poetic to me. I will find it here. Alright, so I'm going to pause the action here as I search for that dropped resistor. Alright, I've located the missing resistor. So this one is the 100K. And I'm just going to pop it in right here. Yeah, when I was a teenager I liked electronics, but everything was so expensive. It was not a cheap hobby to get into, really, compared to as it is today. You know, you'd spend a fair amount of money and get one electronics kit, and then that would have to satisfy you. Nowadays you can spend $10 and buy 5 kits directly from China. And this particular kit probably would have cost you $100 when I was a teenager, but this one cost me $100 in those days was a lot of money. But I believe this kit cost me something like $15. Alright, tack that down in the proper spot. It's always fun to make fixes. Okay. Alright, this was the spot here, I believe. Alright, now to put the 1.5K in the proper location. Let's go ahead and test it again. Alright, yeah, 1,489 ohms, so 1.5K. In the proper position here. So anyhow, over the course of 4 videos, this is going to be part 1, and I'll be wrapping it up very shortly here, as soon as I am able to work this resistor back in and solder it. It's okay to make mistakes. Mistakes are how we learn, and it's very healthy to be able to admit your mistakes, I've found. If you assume that your work is without flaw, then it's not a realistic way to live, because it never will be. Alright, well, I got both leads poked in. Yeah, when you're good at admitting your mistakes, you tend to become a lot better at whatever it is that you're doing. Whether it's writing software or doing circuits or anything in life, really. You don't have to be overly critical of yourself, but and don't necessarily listen to somebody else's criticism. But you know you. And that is good enough. Good fun times getting these resistors all soldered in and the leads cut. And the next part will be hopefully working on the capacitors. So, signing off for now. Hope to see you guys soon.